Wait, what was the topic again?
Complex numbers and operations. Okay, so so why do we need to learn about complex numbers? That's a key question. Why do we have to deal with it? We have to deal with complex numbers because not all numbers are things you can find in the number system. Not every number existing are what you can find in number system. So if you try to locate some numbers in number system, it is not going to be there. It will not fit. You won't get any this thing. So also, by its nature, complex number also appears in nature, especially in science, especially in electricity. The very electricity that is giving us power for us to do this thing right now we are doing, and in electronics, including your computers. So when you look at, for example, the motherboard of your computer, every computer you have, both the cell phone and all these gadgets that you use, it has a motherboard. Then on that motherboard, there are so many electronic connections in there. Things like resistors, capacitors, diodes, several different types of electronic components that are joined together one way or another. So some of those electronic components, they use complex numbers in electrical circuits. So it is real. Having said that, so from mathematics, we also know that several expressions or equations result in quadratic equation. So now, while trying to solve this quadratic equation, we also discover that some will show you a real number, just one value. Some will show you two real values, and some will show you a complex number. Okay? So, which means, so we need to learn how to manipulate these complex numbers when they show up in whatever we are doing, whether it is in science, whether it's in technology, whether it's in engineering, or whether it's for academic purposes. So whenever the complex number shows up, we need to learn or know how to manipulate them. So that's why we have to learn this topic. So now let's give some examples of a quadratic equation, and then we will try to solve it, and we will see what it gives us, and we take it from there. So let's give a typical example. So you can call it example 1. So solve the equation x squared plus 9 equal to 0. So now, true or false? I need an answer. True or false? Just answer true or false. Is this a quadratic equation?
False.
False. So why is it not a quadratic equation?
It doesn't have x squared x and the constant c.
Okay, it doesn't have x component. Is that what you said?
I mean, it's missing bx because it has a and c.
Okay, that's logical. That's logical. Somebody said it is missing bx. So somebody is referring to this general expression, ax squared plus bx plus c equal to 0. So now based on this, the speaker is implying that because it doesn't have bx, then that it is not a quadratic equation. Okay, that's a good logic. I appreciate that. It's a very nice logic. But here's the but there. The but is, it is a quadratic equation and it does have bx. It does have bx. It's just that the value of b is 0. So which means this equation we can rewrite as x squared plus 0x plus 9 equal to 0. So it does have a b. All right? Does it make sense now?
Yes.
Yes.
Okay, so now, which method do you want us to use in solving for this? Let's use the completing of square, or let's use quadratic equation formula. Let's make it fast. Let's use quadratic equation formula, okay? So Let's use x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Let's do this and see what it gives us. Okay, so now let's see. So our a is equal to what? Yes, a is equal to 1, then b is equal to what? 0, and c is equal to what? 9. So if we make all those substitutions, let's see what it gives us. Trust the process, and then the solution will take care of itself. So we're going to have x is equal to negative 0 plus or minus square root of 0 squared minus 4 times what?
1.
Times 1 times 9. Then divide by what?
2 times 1.
2 times 1. Thank you. Okay, so let's trust the process. And of course, minus 0 is 0, right? So this takes care of itself, gone. And we are left with plus or minus square root of 0 times 0 is 0. So you're having negative 4 times 4 times 1 is 4 times 9 is what? 36. 36. So this is negative 36. Then that's divide by, okay. And then at this point, try to use your calculator. And then try to do negative 36. So negative 36, what does it give you? Do it quickly. Let's see. Try to use your calculator. I need a response.
Mr. K.
Yes,
Mr.
go ahead.
16.
What?
Wouldn't it be 6i?
It could be, but I want you to use your calculator first. Tell me what the calculator shows when you try to do square root of negative 36.
It doesn't work. It just says error.
It says error, right? It says error.
Yes.
Okay.
Yes.
So hold on. Please use your calculator unless they say don't use calculator. So when in doubt, use your calculator. So now let's try to do it together. Second function, square root. I hope you can see my calculator, right?
Yes.
Negative 36. Then you come out of this, and then that's a square root, and then you hit enter. You see, it gave error. So which means from the conventional square root, it is not possible to do a square root of a negative number. It is not. All right. So that's just what this one shows. So let's get back to our screen. So it is not possible to do a square root of a negative number. So now in that case, you have to rewrite this plus or minus square root of 36 multiplied by square root of negative 1 divided by 2. Okay, so now negative 1, square root of negative 1 is a special number that is called imaginary. So square root of negative 1 is called imaginary, or you can call it iota. It is actually the word iota or imaginary. Iota means very, very small, very, very small. All right. So, and then of course we can always do square root of 36. So we are going to have plus or minus square root of 36 is 6, and square root of negative 1 is I. Then that's divided by 2. So this gives us plus or minus 3i, and that's x. So x is 3i because 6 divided by 2 is 3. All right. So x is equal to 3i. That means x1 is equal, this is plus or minus, x1 is equal to plus 3i, and x2 is equal to minus 3i.
Mr. Ukaegbu,
Yes.
but at the beginning, couldn't you have subtracted 9 and then square rooted? Then you would have got plus or minus 3i.
Yes.
Instead of
Yes.
doing the quadratic equation.
Yes, you are correct. We could have done that. I purposely did not do that The reason why I didn't do that is because there was a kind of a doubt whether this was a quadratic equation or not. As a matter of fact, some people were convinced that it was not, and that's logical, that's normal, that's okay. So the purpose why I'm using quadratic equation to solve it is because I want to show that that expression is also a quadratic equation. Does that make sense?
Yeah.
So in other words, if somebody asks you to solve this equation, just like you meet it in SAT or any other test, unless quadratic equation, you are asked to do that using quadratic equation, you can just do it straight. You can just do, we had x squared plus 9 equal to 0. So you can just subtract 9 from both sides, you know, plus 9 minus 9 equal to 0 minus 9. And that's x squared. And then this crosses out, and you will have x equal to negative 9. And this, I'm sorry, x squared. X squared is equal to negative 9. And you could have also done squaring both sides, you know, square rooting both sides. So you have x squared equal to square root of plus or minus negative 9. And that could have given you plus or minus square root of 9 multiplied by square root of negative 1. Okay? So that could have given you this result, and which could have given you plus or minus 3i. So this one is a lot faster. You can even do it in a shorter step.
Wait, what's the point of this square root of -1?
Yeah, the point of it is when we try to do the square root of any negative number, it is not possible. And that's why even your calculator gives you error. And that was why I wanted you to use the calculator to show me that error. That's the point.
I have a question.
Yes, please go ahead.
Don't erase. So right there it says x squared equals to -9. Then at the bottom, the plus or negative.
Is it this one? This one. Look at my mouse. Is it this place or this place?
Both.
Okay. So where do you want us to start?
Originally it says x squared equals -9.
Right? Originally, the question was x squared plus 9 equal to 0. That was the original equation. Then we subtracted 9 from both sides because we are solving for x. So we have to subtract 9 from both sides. And when we subtract 9 from both sides, that's how we got.
I understand. I'm talking about how the plus negative disappears.
The negative?
The plus and negative right beside the.
Oh, the plus or minus did not disappear. It is still there. Each time you do, hold on. Let me explain this again. Each time you do a square root of any number, you are likely going to get two results, either a plus or minus. And that's why this plus or minus came about. Now, since it is there, you can see that -9 can be written as 9 multiplied by -1. Same number, we just write it in a different way. You know, remember you are rewriting expression or rewriting number. So our goal, the only reason why we are writing it this way is to help us figure out a square root that has a negative number. So that's why I wrote plus or minus square root of 9 multiplied by square root of -1. So now this -1 has already been defined as imaginary, square root of -1, and that is the I. And square root of 9 is a perfect square. 9 is a perfect square, so square root of 9 is 3. Square root of 9 is 3. Okay, so that's how. So now your real solutions are x1 equal to 3i and x2 equal to -3i. These are two possible solutions. Okay, so now it gave us a complex number. So why we are doing this is just so that everybody will be 100% sure that quadratic equations lead to complex numbers. Now that that is settled, we are now going to go into the processes of manipulating complex numbers. That's what we are going to right now. Okay? So shortly before we do that, we need to define something. I have already defined imaginary number here. So there's another thing that we have to define. So so a complex number, that's a definition now. Definition. Let me write it down quickly, and somebody will help me read it. Okay, a complex number or complex numbers, so it depends on how you say it. A complex number is, or complex numbers are, numbers that can be written as a plus bi, where a and b are real numbers. Okay, so where a and b are real numbers. All right, so any number that can be written in this form is a complex number. So if you want to write it differently, you can write a plus b square root of -1. That is b multiplied by square root of -1. It's the same thing with this. So any number that can be written in this form is a complex number. Now let's look at the solutions we just presented. Let's look at these two solutions. This one, these two. This solution x1 can be written as 0 plus 3i, and x2 can be written as 0 minus 3i. All right, so in this case, 0 is a real number, 3 is a real number. So your number is in form of a plus bi. So now that we know how to write a complex number, let's give other examples of complex numbers. Another example, just give me another example of a complex number. We're not solving anything. Another example of complex number. Just give me any you can remember. Is, yeah, I'm listening. Volunteer. Any number that can be written in this form is a complex number. So give me a number that can be written in this form.
2 plus 3i.
Okay, 2 plus 3i is a complex number. That's correct. All right, so we are done with that.